Hey everyone, this is Matt with Learn Everything About Design, and in today's video, we're going to walk through the process of designing a wireless phone charger stand. Now, I have a lot of 3D prints in the house, many that I use every day, and one of the more common parts that I use is a phone stand. Now, we've done several videos on these phone stands. We've done them in Fusion, we've done them in plasticity. We did a course in our learneverythingaboutdesign.com website where it was an introduction to 3D printing, and we built a phone stand that had an amplifier in it. So I've done a bunch of these phone stands, and I use them all the time. I have them pretty much everywhere I go in the house. I've got one on my desk, next to the bed, and one in the kitchen. And they're just extremely handy because you can set your phone down. You can still look at the screen if you're looking at a recipe, if you're watching a video. They're just really handy to have around. Now, my phone started to have problems with the USB-C connector charging a little while ago. I have one or two cables that work. Most other cables will not charge the phone. So I needed to design or buy a wireless phone charger. Now, most of the ones that I found didn't have all the features that I wanted. So in this case, we're going to set about designing our own. This one can hold the phone sideways or it can hold it vertically. It'll charge in both orientations. And we're using off-the-shelf parts in a 3D printer so we can customize the design to fit whatever phone or whatever device we want. Now, we're not going to walk through every step of this process because the chances of you designing the exact same thing that we have here are pretty slim. So what we're going to be doing is talking about the decisions that we made along the way. We're going to work through the process of setting up some of these base references, talk about how everything is going to go together, and some of the tools that we use, like the sweep tool, the shell tool, some surfacing tools, in order to create this final assembly. Now, the first step of the process is to get the electronics. Now, I am a big supporter of Adafruit. I think they make great quality products. We're not sponsored at all by them, but in most of the projects that I do with PCBs, I go to Adafruit as my first stop to see if they have what I need. Now, they have this universal QI wireless charging transmitter. Most wireless devices, or most devices, phones, tablets, and things like that, have adopted this style of charging. So if you have a phone that's, over the last couple years at the very least, it should already support this. Now, if it doesn't support this, then there are actually options that you can buy. Things like these receiver pads with the USB-C or different connectors on them that you can plug into your phone, you can put under a cover, and you can still use wireless charging. Adafruit actually does also have receivers. They're out of stock right now, and it's a little bit more cumbersome than some of the other ones that you can get with the USB-C connector, but it is an option if you are doing wireless projects to get both the wireless charging transmitter and the receiver. So one thing to keep in mind that with Adafruit, when they design their own circuit boards, all of that stuff they provide to us. So we can download a 3D model of the microcontrollers. This is different because they are actually supplying this for a vendor. And so what you see on the screen is not exactly what you're going to get. And what I mean by that is the version that I got, the backing for the coil is round. This one's square. There is a chance that the PCB will be slightly different. The one that I have has a USB-A on it as well as a micro B. It doesn't have a USB-C. It also looks like this connector sticks off quite a bit further than the one that I have. So it's important that once we get something like this for our own projects, that we can take basic measurements and we can model it for ourselves. Now, if you happen to get the exact same one that we have here, you can use the download link in the file. I've included a download link to a basic phone as well as one that has the electronics here set at 60 degrees. So what I did was I took basic measurements, the overall size of the circuit board, the size and locations of the holes with standard calipers, as well as the size and locations of the different connectors. Now, you're going to oversize these slightly, and because we're 3D printing, we're going to give a little bit more room around them, typically about 1 millimeter, just because of any inaccuracies in the print, problems with areas where we may need to have support, for example. So it's just good to leave a little bit of extra material around the 3D model, and then also to have a gap around it on the parts we design. Now, the tricky part for this was actually the cables. I have some placeholder cables here. This was about as far as I could get these two components apart. Now, for my specific phone, the coil needed to be in the center of the back of the phone. For other phones, if you've got, let's say, a flip phone, for example, it needs to be in the center of the bottom portion of the phone. Other phones may be in different locations. Most of them happen to be in the center unless you do have a flip phone, but that's something that you need to figure out. The wireless charging settings in your phone typically will tell you where it is, but it's important to get these components and play around with it first. So once we have that model ready, I've got mine set back at 60 degrees. I find that that's a good angle to keep the phone. It also helps with the center of mass because with a phone, the center of mass should really be somewhere in the middle of the base. And if we happen to use it in a horizontal fashion, the center of mass is actually just slightly in this, a little bit lower, but it's pretty close to the same spot. And this helps making sure that the overall thing is stable. If you happen to make the base shorter or try to make it shorter, and the center of mass is too close to this back edge, you're going to find that it wants to tip back and it's not going to be very stable. So keeping that angle a little bit closer to vertical or making sure that the base itself is long enough so that the center of mass is not near the back edge but somewhere in the middle, that will help make sure that it's fairly stable. We're also going to build this in two pieces. We're going to talk about design for assembly, things that we may run into issues with 3D prints or with tolerances. And then hopefully at the end of this, you'll be able to design your own. So to get started, if you want to follow along or you want to build your own, there is a download link in the description of the video. That includes the phone in two orientations, as well as the wireless charger PCB and coil that's set up in the back center of the phone. So the first step in this process for me, generally, is to start from a single direction. So when I'm designing a component like this, I'll either look at the overall assembly from the side or from the top and try to get a rough idea of the shape that I'm looking for. So for this design, I'm going to start a sketch on the side. Typically, I will go through and I'll slice it, so basically a temporary section view, so I can kind of see what I'm working with here. Then I'll go to my project include and intersect. I'll get the back of the phone. And also, in this case, I'm going to get the bottom, this arc here. And then let's go ahead and get the PCB. Also, we're going to get the top, bottom, and the back. And we'll just get the front just for good measure. Now, you can use this option to do the entire body. But when we do that, we're going to end up getting things like section views for the coil and the inside and things that we don't really want because they're all included in this one solid body. All right. So now that I have those references, I can start to create the rough 2D profile. And when I say rough 2D profile, this is generally what we end up using. So I'm going to start up here on this intersection curve and I'm going to come down perpendicular. I'm going to come down here. I'm going to hold down the left mouse button to do an arc. I'm going to come back, down, back over. Do another arc, and then we're going to call it good. Now with this, we need to go back and add a tangent relationship here, and we'll need to add one between these two, and then we can give it some rough dimensions. So as we're looking at this, we can begin pulling it so that visually it looks right, keeping in mind that what we're looking at is the outside. We're going to have a wall thickness, and in this case, what I'm going to do is about 2.5 millimeters. 3 is probably too thick because it'll just make the overall thing much bulkier. 2 may be too thin for it to be very sturdy. So 2.5 is probably a good sort of in-between number. So as we look at this, a couple of things that we should consider. If we want the base to be basically tangent, if we want the bottom of the phone to stop on that position, then we're going to create another line. I'm going to just snap here and come out horizontal. We're going to convert this to construction, and then we're going to add a tangent relationship with that and this arc here. So it's going to move everything up. So this gives me my bottom position. I can then add a dimension here, let's say a 5 millimeter radius. Actually, let's make that a little bit smaller. Let's make it 3. The reason I want to make it smaller is because the way I'm going to hold the phone is with a small bump in the bottom corner. Most phones have fairly large radii if you're looking at the screen on those bottom corners, and just bumping them out a little bit will give us enough to grip the phone. The next thing that we need to do is figure out the overall height here. So I'm going to just go from this point here, right click and make it aligned. And let's try 95. That'll probably give me enough room above this. We can always come back and adjust these, like make it a little bit bigger, 96. And then let's try to do this, right click and aligned. And I want to go as thin as possible here, making it, keeping in mind that we're going to have to sink this into the material to help it align. So this, I don't need 2.5 millimeters between the back and here, and I don't need it between the front and here. So that way I can just sink that in as long as I've got at least, let's say 6 millimeters here. That gives me 2.5 on the back, 2.5 on the front, and then I've got a millimeter gap in between them. So that way it'll help me sandwich it and give me enough room for those wires or cables to come out. Then I need to do a radius value here. Let's try something large like 10. And then I need to figure out the overall height of this piece here. So 10 may not be thick enough. If I make it 13, that gives me enough material. And the reason I say that is if I turn off slice, remember that we've got a connector on top that's not seen. So in the version of the board that I have, the large USB is on the bottom or on this side, the bottom in this orientation, and the USB micro B is on top. So I will need to make sure that those are in a position where I can actually do that. The next thing we need to do is figure out how far back this needs to come. Now, in general, let's go ahead and just drag it back. In general, we need to have a little bit of material between the end of the board and the back. The connectors can stick out, but the board can't. We really don't want it to. So I'm going to use, hit D, not extrude. I'm going to hit D, and then let's say 58 millimeters and see what that looks like. All right, that may be a bit much. Let's try. All right, let's go. I'm going to go down to 56. All right, so this connector is just barely poking out. We still have some room. If we measure this, it's got a millimeter between the board, the back of the board, and this cover. It's not much, but that will probably be enough. Just for good measure, I'm going to do 56.5. All right, so that looks pretty good. So this is basically the starting point for us. I'm going to go ahead and finish the sketch and hit E to extrude and take this entire profile, also the board because we had a closed profile there. We're going to do this as a symmetric extrude with an overall or whole length width, and then begin to drag it out. Now this is going to be a new body, and the overall width needs to be wide enough or wider than the phone because we're grabbing it around the outside. At least to make it a little bit easier to print in certain orientations. We can, of course, bump those features out and around if we want, but it'll be a bit stronger if we just make the whole stand wider. It's not needed for the electronics, but again, just for stability's sake, making it slightly wider than the phone will help. So what width do we need? Well, remember that my phone is about 75 millimeters wide on the outside of the case. I want at least a little bit of a gap there. If I make the holders exactly that width, then they're going to end up just being too tight. The phone will get stuck if I try to pull it out, and it might not even go in at all. So we want at least a little bit of a gap there. So 76 millimeters plus enough material so that these pieces aren't flimsy. So I think if I go to, let's say 82 millimeters, that's going to allow me enough room to make those side pieces thick enough with a gap around the phone, and that way I don't have to worry about them breaking. So now that's the base of the design. Now the next thing that we need to do is, I'm going to hide the phone for now. The next thing that we need to do is start to work on the general shape. And what I mean by that is, for example, if we want the top to be rounded, let's say 15 millimeters, once we get the overall shape, and when I say overall shape, I don't mean including things like a bunch of tiny fillets. Those will all come later in the design. But once we've got this base shape down, we can start adding those pieces that hold the phone, and then we can go ahead and make a duplicate of this so that we can build out the back piece. So I'm going to bring the phone back. I am going to make an offset plane from the bottom here. I'll view this from the right side. And this offset plane is going to, it looks like 10 millimeters might be okay. This is going to be where those sort of grip pieces start. Once we have a plane there, we can begin sketching. And again, if you do slice, this will kind of show you what you're working with. I want to do an intersection curve with the phone base that we just created. And we're going to use look at. And the reason for this is because now I can take this piece out and I can start to design the parts that are going to hold the phone in place. And what we're going to end up doing is mirroring this. So I'll add another line here. Then I'll convert it to construction with X on the keyboard. And now I can start to define these sizes. So another thing that we could do actually is instead of making this a construction line, we'll make it a center line. And this makes it easier if I dimension from there to say here. It's going to give me the overall width distance. So I'm going to say 76 millimeters. And that way, when I mirror it to the other side, I know that I'll have 76 there. I can also do that for this part here and say that we want 65 millimeters there. And then this is just going to be kind of a standard number. Now, the overall height of my phone, measuring it is like 11 millimeters. So if we do something like 12 or even 13, it doesn't need to be tight. The phone can rock back and forth. Just make sure that we have enough of a gap here. The width of the 3D model is not 75. It's a little bit narrower because it's not really including the full width of the case. But for the purposes of this, we're going to rely on the dimensions. And then also we need to deal with the overall height of this. The majority of this is going to be 2.5 millimeters. That's probably going to be too thin. If I make it thicker right now, it's likely going to cause problems when we go to shell. So we're going to shell it at 2.5 millimeters. So this can't be any larger than 5, or else it'll try to create a hollow section in between it. But we don't want it to be so thin that it's not strong enough for what we need, because this part's going to get raised up so we can hold the phone in the sideways orientation. So once we're happy with that, hit escape to get off our dimension tool, double click to select the profile, and then we're going to mirror this across that line. And next we're going to show the phone in landscape mode. We're going to extrude, so select both of these profiles, and we want them to go all the way up to this object. We're going to hide the phone, and that way it's only going to join it with the base, and we'll say OK. Next, we're going to create another sketch on this face. We're going to select this one and P to project, and then we're just going to use a line to go between those points and those points there. So now extrude again, so E on the keyboard, and we'll pull these up. So they don't really need to go super high to hold a phone, at least 5 millimeters. You may find with your phone, depending on how big of a radius it has, you may want to go up as much as, say, 8 millimeters. And then now, if you have a phone in landscape mode, it will hold it in position, and then it won't affect us at all in this orientation. So we're not going to spend a bunch of time adding fillets and things like that, but we do need to add the bottom piece that's going to hold the phone. And what I mean by that is when the phone is in this orientation, we want it to narrow so that it's preventing the phone from dropping all the way down. If the phone drops all the way through, the base itself is not going to be heavy enough to keep the phone in place. Now, if the base, the charger station, was heavier than the phone, it might be fine. But in our case, the 3D print and electronics are not nearly heavy enough. So what we're going to do is we're going to create a sketch on this face. So right click and create a new sketch. And then I'm going to use my line tool. I'm going to come down a little bit, then hold down the left mouse button and create an arc. I'm going to come straight down, straight over. I'm going to hover over this so I've got a reference, and then back to here. And again, we're going to put a center reference line. I'm going to hit X for construction. And essentially what we want to do is we want to just create a little piece or a little block. D for dimension. Don't really need to fully dimension this, but I'm going to give it 3 millimeters here. Overall height here, I'll say 10. And this one needs a dimension here, we'll say 2. And then escape, double click, and mirror. All right, and then we'll finish that. So hide the phone, E to extrude, select all these profiles, We're going to be going two directions, so I'm going to bring this up slightly, which is, again, it doesn't need to be really that much material. We're going to go two sides, and we're going to pull this down, joining them together. And then we're going to use split body, using the bottom face, and then take these other little pieces, right click and remove. So that allowed us to extend those pieces out. We will need to be careful when we go to shell this thing that we don't have any area that's more than 5 millimeters. If we do, then likely what we want to do is shell it before we add these. Again, we're going to put like a large fillet in there, but for right now, let's go ahead and just work with this. So hide the electronics and then take the entire thing and do a copy and paste. So Control C and Control V. Hide the copy and then use shell, select the back in this bottom piece and say 2.5 millimeters. So what this will allow us to do is create a shelled version of this. Now there's a radius here, which we don't really need. So you can select and hit delete and it'll leave us with a square corner. And now we've got the inside that should be enough for all of our electronics. You can see there's a little bit of an overlap here. We can cut out space for that. We can also reduce the wall thickness to 2 millimeters if we need to. We can also move things up or down as needed. So just keep in mind that while these things are fixed as a 3D model in the design, these are soft wires. They're cables that can move and flex. So if we need to move the PCB up just slightly and keep this in the same location, we can do that. It would require you changing the original design, which is brought in, and the link was broken, so all the features are here. But we're not going to go through that. Again, for our example, we're just going to go ahead and make some of these basic design decisions. So everything looks okay. Now let's talk about how we're going to get the back piece. So we're going to bring back the solid version on our surfaces tab. We're going to say offset, and we're going to offset that. So create a surface, and then we will thicken this 2.5 millimeters. We're going to say okay. Body 16, this full body we don't need. I can right click and remove it. But the version that has the shell in it, we're going to bring that back and we're going to use combine. So we're going to use the cut option. We're going to cut away from that thickened surface. We're going to be using the main body and make sure that we have keep tools selected. This will ensure that we keep the original body that we shelled. And now we should have something where the parts exactly fit. Now, in reality, we can't have them exactly fit. We will need a gap, but we're going to take care of that a little bit later in the design. For right now, just note that we've got the front piece and we've got the back piece. It's a good idea to rename these. So we're going to just call this back, call this front. And since we haven't saved anything yet, it's also a good idea to go ahead and save it. So let's go ahead and save this. Once we have it saved, this is now the part of the design where we start to add little details. So rounding corners off, adding these fillets, and smoothing out the majority of the design. And then we need to focus our attention on the features that are going to lock everything together. Now, the order in which you do this is really up to you. There's not really any pro or con to doing one before the other. We're not going to be adding a lot of features that are going to basically interfere with us adding things like holding the PCB in place. But it's really up to you in the design process whether or not you want to leave the fillets and the small details till the very end, or if you want to start to add them now for reasons that may come into play in your design. So for example, this corner right here, we may decide that we want to round it before we cut open any spots for the connectors. And the main reason that we would do something like that is because when we are going to, let's say, cut holes in here for the connectors, when we come back and do a fillet, that means we're going to be selecting multiple edges. But if we add the fillet beforehand to these edges on the sides and this one here, then we can just do a single cut and then the fillet is before it, and it really doesn't matter. You can modify one before the other. There are going to be some cases where it makes more sense to do certain features first if they're going to impact or rely on areas of the design. For this one, however, there's really no impact that I can think of doing some of those detailed design pieces and then adding those design features. I think what I want to do in this case is add some of those design features where we're going to add screw holes and snap things together, simply because that's probably more important to the design process than just adding a bunch of fillets. So at this point, if you do want to add fillets, go ahead and pause, add all the ones you want, round and smooth everything out, and then we'll come back and then we'll use some tools to add things like sweeps and edges to snap the parts together. All right, so let's tackle how things are going to bolt together. So this is often an area where it can be difficult because we have to think about 3D print tolerances. How tight can the parts actually be? And if we print them to exactly fit like this, they will not fit. They will 100% guaranteed not fit. And part of it is because the layer lines, as we go up and around these arcs, are going to leave jagged edges because it doesn't really do the arcs very well in the Z direction. So as we're building up vertically. And another reason is just we generally need to have a small gap between 3D printed parts. 0.2 millimeters is generally good for parts that don't need to move or slide. 0.4 is good for parts that need to move around, things like articulating joints, larger if you need a looser fit, for example. So when I'm looking at an assembly like this, I am going to be thinking about using screws that go from the back piece through the PCB and into the base. I can't get to the back two screws just because of the geometry without putting some holes in the design, and that doesn't really work because the charging coil is there. So I need to figure out a different way. Another thing that we want to consider is that as we plug a USB into this, it's going to be pushing back on the screw, and eventually it's going to wear the holes out, the threads are going to get broken. So having a wall at the back of the PCB is going to be important. Also, with this USB, likely I want to just raise it up. So I'm going to use my measure tool, which is I on the keyboard. And we can see that we've got about 0.8 millimeters there, so we can move it up 1 millimeter. But we want to keep the disc in the right location. So what I'm going to do first is I'm going to take care of basically the gap for this. So I'm going to start a sketch by selecting this face. We're going to create a circle that's going to be slightly larger than it. So the disc on the part that I have is about 50 millimeters. So I'm going to just add 1 millimeter. And then I want to make these construction on the inside so that I don't accidentally select them with the profile. Then we'll bring back the front and we'll extrude. And essentially what we're doing is we are going to leave a gap. So I'm going to extrude back this way. And I'm going to say 2 sides. And I'm going to leave a 0.5 millimeter gap or a millimeter gap. And the reason for that, and let's go ahead and do a section analysis. But the reason for that is because, again, the coil wires are sitting on top of the coil. Like the one that enters the coil is fine, but the one that comes back is not fine. This can cause potential problems when we're printing if we make this gap, this section too thin. So for example, if this is 0.5 millimeter and one trace of the 3D printer is 0.4 millimeters, and we're building this up at an angle, this means that this section can get pretty squirrely. So because of that, what I'm going to do is instead of doing 1 millimeter, I'm going to do minus 0.5. That should give us enough room for the wires. We can also sink it into the back a little bit more. This coil is actually pretty good. It'll work up to like 8 millimeters through about 5 to 8 millimeters of plastic. So it doesn't need to be that close to the phone. The other thing that we want to do is account for that on the back side as well. So we already have a sketch, which is this sketch here. And if we bring the back into play and we extrude this, what we're going to do is instead of profile plane, we're going to start from the back of an object. So the back of the object that we want to start from is going to be the back of that cylinder there. What you can see here is that it's not really displaying properly. So I'm going to turn off my section analysis. And let's just call this a new body for now. All right, so we're going to start from the back of that and go forward. And we want to take it away from this piece and not that piece. So we'll do a cut. You can also use options like to object to cut to that face. And if you need to leave more room or more gap or make any changes, we can always go back, hold down Control. Now you notice what it's actually doing is it's selecting that face and it didn't select the sketch. So we're going to clear our selection and make sure that we're using the sketch. You may need to hide your objects again. In this case, make a selection on the back, bring back the back piece. Now, I wish this was a little bit easier in Fusion. It's not bad, but it definitely could be better. All right. Another thing I do after the fact sometimes is if I want to make changes, I can select and use tools like press pull and say minus 0.5 to give us a little bit more space because we've got more material on the back. Because we didn't take it all the way to that millimeter in the front piece, sometimes this can help. Also, keep in mind that the wires coming out of those coils are going to be on the front side of the backing plate. And it should be fine here, but you may end up, depending on how deep you take this, you may end up needing actually a little bit of a trough or a section for those wires to go. I think it's going to be fine in this case, but something to keep in mind. All right, so you can see here, in reality, this is not a perfect 3D model of it, but it gives us a good idea about where they are. All right, so now that we have that and we've accounted for that, the main reason I wanted to do this is because I want to move this up that 0.8 millimeters. So we're going to use move. I'm going to click this direction, and because it's pointing down, we're going to say minus 1 millimeter. You notice that it's not moving the component. Now, part of the reason for that is because there is a relationships here. The component itself actually has a constraint with it, and it's constraining itself to a reference sketch that I put on the back of the part. Now, because of that, it's not allowing the component to move. If instead we changed bodies and we selected this body here and we said minus 1 millimeter, the body is inside of the component and it will move the body relative to the coordinate system. So when we think about things like constraints and joints, those actually apply to the coordinate systems between components. So if we go to the origin here, that origin is going to be what it's tracking in relationship to the top level origin, for example. So if we go before the move, notice that the body itself is moving relative to the coordinate system that's a part of the wireless charger here. If you need to, again, you can always go back and make changes to the physical location of these parts, but that's just something to keep in mind. All right. Now, in reality, I didn't actually need to do that or move that, but it does help just visually understanding where these things are. So now that we've got that sort of taken care of, the next thing to do is to account for the screw bosses. And to do that, I'm going to start a sketch on this bottom face here. And the main reason I want to do that is because I don't want it to bring in the profile of all of the different pieces on this PCB. Now, if we happen to have a full detailed PCB model, that could be really bad as well, because we'd have all the little components and so on. So we're going to select project. I'm just going to take each of these locations, as well as the back edge of the board. And now if I hide this, we've got the location for each of these holes. I'm going to select them and turn them into construction. And then use the circle tool and just add additional bosses. Now, when we're dealing with things like injection molded plastic, we have to be real careful with the size of these, but for 3D print, it's not as big of a deal. I'm going to make them 5 millimeter and then make them all equal. When I do an equal relationship like this, I tend to go back to the original object, just simply because if you make these two equal and then you move to these two and you end up deleting one or changing one, what ends up happening is you break that relationship. If they're all tied back to the one that has the dimension, it's pretty easy to remember which one was which. Also, for the hole in the center of this, I am going to be using a 2.5 millimeter diameter hole. And that's going to be an appropriate size for the screws that I'm using. But before I do that, I'm going to make these larger, so that way they're easier to select from further away. And then I'm going to use my dimension tool to add that 2.5 millimeter dimension. So if they ended up being smaller, it's really close to this size and it's easy to accidentally select that. So that's why sometimes I do that. I make the geometry a bit bigger. And the other thing that we need to do is we need to create the wall for the back of the PCB. So I'm going to use that projected reference, and I'm just going to come over on either side. And then I'm going to create a secondary line, give it a dimension here. 2.5 millimeters is the overall wall thickness. Again, if this was an injection molded part, it would need to be 60 to 75% of that. For our purposes, it doesn't matter. Actually, having a thicker wall might help. We could actually take the wall all the way over to here. There's nothing that needs to go there, but this wall is going to be the support that the PCB pushes up against. There will be an area in the center that needs to be open for the cables. So what we're going to do is just add some additional lines here and then give them a dimension. You really don't need to worry too much about specifics for things like this for the cable passage. It doesn't have to, I don't need to go in and measure it. It's roughly 10 millimeters wide, so making it 20 is going to give me more than enough room. But for things like the hole positions, those are quite a bit more important. All right, so let's bring the PCB back and let's start by extruding this wall. So we're going to pick both these sides, and we need to come up so that it's above the PCB. We are going to join it, and this will not join it to this component here. It's only going to join to the base that's visible at the top level. The next thing we need to do is take care of all the screw bosses. So hold down Control. I'm going to select each one of these. Because we made the original projection construction, it's not going to include it in the profile. And then I'm going to say all the way up to Object. So I'm going to take it all the way to here and have those join. Once again, the reason that we are doing this is we're not going to be able to screw into the back. It's just there's not enough room to get a screwdriver in here. You could potentially do it with a tiny screwdriver, but it's not worth it. This wall on the back will keep the PCB in the correct orientation. The screws in the front are going to allow it to lock or locate in place. Because the difference between the hole size and the board size, there's 3.15 is the diameter on the board, gives us enough of a wiggle room if the screw bosses are off just slightly. I'm not going to get too into the details of things like tolerance for a part like this. All right, so now that we've got that taken care of, the back also needs holes in the correct location. So what I'm going to do is start a new sketch on the back. I am going to use Slice, so it kind of gets rid of that top piece. I'm actually going to hide the back altogether and bring back the previous sketch and use Project just for these two center locations. So just the center points, and we'll hide that sketch and then use my circle tool. So I need a 5 millimeter diameter hole for the basically the counter bore to have enough room for the screw head. And then I need at least a 3 millimeter hole. I'm going to make this 3.5, slightly larger than the hole in the PCB. And the main reason for that is just, again, a little bit more flexibility when we're talking about parts aligning. Once we screw these down, we are essentially, we're going to be locking it in place. It allows for a little bit of misalignment. These parts don't need to fit perfectly. But once we have this, we're going to say extrude. I'm going to take both of these, and remember that we are 2.5 millimeters thick. I'm going to take this down -2, leaving only 0.5 millimeter there. It doesn't need to be much. And then we're going to extrude the center point. We're going to say through all, but the object to cut is just going to be the back piece. We don't want to cut through the PCB, and then I can hide that sketch. All right, so now I have the location for the screws. I need to deal with actually getting these parts to fit. I need openings for the connectors, if we need an opening for the LEDs, if we need to see those. And then I need to deal with the tolerances or the gap between these and add a little feature that helps them lock in place. Remember, we're not screwing the top together. We could certainly add screw bosses. 3D printing a part like this, I'm likely going to, I've already made one of these. So I'm going to set it on the build plate like this and allow it to print vertically. That is not the best orientation to get the highest quality out of this. For example, we're going to see layer lines on the front of these edges if we use a standard PLA. I could lay it on its side and print that way, and this would give me better quality on the faces that we would see here. But the problem is we would need a lot of support on the inside to be able to hold up these bosses, or we could take the bosses all the way to this wall so that they would build, and then this one would need something like a tapered wall or a rib that came up from the base so that we wouldn't need any support there, and I could carry it all the way to that top wall. Again, we could, if we really needed to, we could do those things, but then this wall would be unsupported. For the most part, we would need to add some sort of support to make it happen. So in a case like this, we can print most of this part without support. We may need some under here. And that's just kind of how I would approach a design like this. So again, these are considerations or factors we need to think about when we're adding these features to our design. How is it going to be printed, and what features can I get away with? So let's go ahead and let's take care of the openings for the connectors, and then we'll deal with how everything sort of fits together. So the first thing I want to do is sketch on the back face. I am going to project that, so P on the keyboard, and then I'm going to offset that 1 millimeter. Again, this gives me more than enough space around it. Then I'm going to convert that to construction. I also want to do this with that small connector, so hold down the left mouse button, select the face, P to project, offset 1 millimeter, double click, convert to construction. And then we can bring the back and extrude. So we're going to take this as well as this and extrude it backwards. This one is going to have to come back far enough for the connector on the PCB. So you can see the connector actually comes all the way back to here. So I need to go back at least 6.5, 7 millimeters. And we only want to cut away from the back. We don't want to cut away from the PCB. So what this means is when we install it, that connector, at least in this iteration of the board, is going to have to sort of go in and pop down over the connector. Totally fine, not a big deal. But it does add some complexity, needing some support for this face here if we build it with this on the build plate and it's going vertically in this direction. Not a big deal, something we can deal with. All right, so now that we've got the holes, the next thing is, notice there is a gap between the top of the board. In my version, all the electronics are actually on this side. The back doesn't really have much going on. I'm going to leave that gap there. If you were worried about things being held tightly, you could add little bosses from the top. That would give a bit more material between the bottom of this boss and the top of the PCB. I am going to let it flex a bit, just simply because I know that 3D prints need a bit of a gap. All right, so the next thing that we're going to deal with is the gap between parts. And to do that, I'm going to use press pull again. I'm going to select the side faces here, including those fillets. And I'm going to say minus 0.4 millimeters. It's going to make it all smaller. So if I bring the front back, we should now see a 0.4 millimeter gap everywhere except for the bottom here. I'm going to leave that as exactly the same size. We could add a gap there, but then we start to deal with screwing down and pinching on the PCB. I want to keep that height as fixed, not necessarily for any specific reason, but it's just something that I like to do. All right, so the next thing that we want to do is make a feature or a little bit of a recess that can lock this piece underneath a ledge. While it's not strictly required, the part would likely be structurally sound enough and hold it. We do have the weight of that coil that's going to be, it's got a sticky back on it. It's going to be adhered to this. And just the weight of that could potentially cause the 3D print to sag. So I want to have some feature that can hold it in place. To do this, I'm going to use the sweep tool. So I'm going to start with this one here. We'll create a sketch. And I'm just going to use a simple rectangle. I'm going to draw a rectangle that is, let's say, 1 by 1. And then we'll add a dimension from the top. I'm going to come down 0.5 millimeter. So we're going to finish the sketch. We're going to sweep that. And we're going to select this edge as our sweep edge. And we're going to join it together. I need to hide the front because I only want to join it to this back piece. When we do this, keep in mind that this is going to cause a problem when we 3D print. And this is, again, this is something that we need to think about. If we're going to try to print this, in reality, the side face where we're adding this little sort of detail or feature here, that side face is the best chance we have at putting this on the build plate and getting good adhesion while we build up in 3D. Adding the lip portion of this to this specific part is going to mean that we no longer have the ability to place it like that. This is something that we need to think about when we start adding these. It could be very easy to add these details or features, get them in 3D, and then realize I just made this thing a lot harder to print. We could print it with this face on Z. So if we look at it from the side, then we would need a ton of support under this. It would look ugly. It would just not work as well. So I'm going to cancel that. Going to go back to that last sketch. And I'm going to rethink this a little bit. So instead of doing this, let's go ahead and delete that entire thing. Instead of doing that, what I want to do is I'm going to make a cutout here. The cutout could potentially cause problems in prints, but I'm going to go ahead and do a 1 by 1. And we'll do our sweep. Again, zoom back in because it likes to zoom out for us. And we're going to sweep and cut that entire edge. All right, so now we've got that little bit of a lip there. In order to deal with or help with 3D printing, I'm going to add a small chamfer here. We could make it as big as 1 millimeter, which would just create that sort of tapered edge. That's probably, if we were going to do that, we wouldn't need to do the sweep cut at all. So if we want to do that full chamfer, I just suggest deleting the sweep cut. If we want to make it smaller and actually have a little bit of a ledge there, this is small enough that when it's 3D printing, that's probably going to be one trace. We would just need to look at the different layers and make sure it's not trying to build this first before it builds the stuff on the inside. Probably fine. I'm going to go ahead and run with it. Next, we'll do a sketch on the back of this face. And again, it tries to zoom back into the origin. On this one, because of the orientation we're printing, I'm going to go ahead and add this lip. So I'm going to say that this one is 0.5 millimeter tall and let's say 3/4 wide. So it's pretty thin, pretty narrow. I'm going to explain that in just a second. And then we want to sweep that. So we'll select the profile. We'll sweep here. We're going to join it together. Because they're not touching, we don't have to worry about them trying to join anything that is not supposed to be joined. And then I'm going to add a chamfer here. If we add 1 millimeter, it's going to be too large. If we add 0.5, that will still give us enough of a gap between parts, and it builds this little bit of an overhang. It's not so big, that overhang is not so big that we can't assemble the parts. I don't know what's going on with the zoom, but it's not so big that we can't assemble the parts. They will still flex. And by adding these tapers, as we're building up in the Z direction, as we're looking at it, it'll start to build this out, and that section right there will be unsupported. But in this orientation, it's probably going to be fine. We could make the chamfer a little bit bigger to help it. The other thing to keep in mind is that I'm going to go ahead and say okay and take a look at our section view. The other thing to keep in mind is the upper section of this. So as we're printing in Z, this upper section is unsupported. So this unsupported section is going to be problematic. And what I mean by that is we're likely going to have some print failure in this area. Something that we could remove a portion of that lip if we wanted to. But for right now, I think it's okay. One thing that this does highlight, if I hide the front and we hide the wireless charger, is that is a very thin section of that part. Now, it could probably still print, but it is pretty thin. So what I'm going to do is I'm going to save this. I'm going to go back to my initial sketch right here. Going to show dimensions. View it from the right-hand side. And remember that all this geometry is based on things like offsets. So if I take this 96 and make it 97, notice that it adds more material there. So that's a bit better. If we want a bit more material there, we just make it 98. It should update everything for us just based on the way that it was modeled. And now you can see that looks like a little bit more material. We're not really going to have too much of a problem there. All this does is it makes it a little bit taller behind the phone, but it's still quite a bit shorter than the phone. Doesn't change the location of any of the other features. So that's one way that we would need to address that. All right, let's do a quick save. And at this point, everything is done with the exception of adding any cosmetic details you want. So rounding corners off, for example. Now, as we approach rounding corners off, it's important to remember what we can actually print and the orientation of these features. So for example, let's add a fillet here and right there. So this is going to be holding the phone, say 5 millimeters, and that's probably going to work out just fine. Going to add another fillet under here. We could add a fillet or actually a large chamfer and completely round this section off. That way it looks a bit better. And then we can round this upper section off. And I'm going to hold down Control, round these bottom sections off as well. And hold down Control. No, not that one. Let's rotate it. This one here. And we can just go through this process of adding these fillets wherever we feel is necessary. So I would suggest doing the larger ones first. So as we begin adding these, do the larger fillets first in the corners where the fillet itself is going to be graphically important. All right, so what I mean by that is if we need to, let's say, round this corner and try to round this corner and this corner and this corner, that is something that affects the overall look and appearance of the design. Fillets that don't really have an impact on the look and appearance of the design are ones that are more like a small 1 or 0.5 millimeter fillet, for example. So let's go ahead and add them here. Maybe to the inside. And these kinds of small fillets likely aren't going to print very well, but they are fillets that visually can cut those sharp edges. And what I mean by that is it's not going to leave a sharp corner, and it will visually soften the design. So I like to add these types of fillets to the outsides of designs and then leave sharp corners where it makes sense, like, for example, in this area. All right, and that is it. So the last step of this is to actually go ahead and export it and 3D print it. I'm going to be printing the final version of this in a PLA CF. The main reason for that is because it works a bit better for the layer lines, the view of the layer lines. Some materials will print better and not show those layer lines. Some will really kind of highlight them depending on the color and the material itself. So what I want to do is make sure that the only things visible are the front and the back. Typically what I do is I right click and I save as mesh and I send it directly to a print slicer. In this case, I want the front and the back visible. I'm going to do an export, and I'm going to export it as an STL. So I'll leave V6 in there. Actually, let's go ahead and just say video. The reason for this is because exporting both those bodies as STLs and then bringing them into a slicer like Bamboo Labs, I can separate them into their own objects, saving myself a little bit of time. Unfortunately, Fusion doesn't allow us to select multiple solid bodies and save them as mesh. We can convert them to components and make that happen, but it doesn't allow it at the body level. All right, I'm gonna skip this version. Go to prepare, add, and I don't know why it goes to that location. Alrighty, so we want the wireless phone charger video. It brings them both in as one object. So with it selected, we're going to split to objects. I'll select one. This one's going to print in this orientation. This one, however, nope, not scale. we want it to print in that orientation. Move it away just slightly. We need to enable supports. I'm going to use tree supports, and I also want to change the material. So I'm going to use the PLA CF from Bamboo Labs, and we'll slice the plate. Now, remember I mentioned that there are a few areas where we are going to likely have problems. Tree support on those is fine. Remember that we have the lip. We made the groove on that thin part because of the print orientation. The holes will print okay unsupported in this case, so I don't want to add any supports. The front edges looks like they need supports. This one here, it's not saying it needs supports, but that is definitely going to be a problem. As we come down to, let's say, level 419. So this is starting to build out into the air. As we go up a level, it's building straight across unsupported. And as we go up a couple more, it's starting to bridge that gap. So that's an area where tree support would likely help. It's not automatically picking it up just based on its angle, but I know that there is going to be a problem with that being unsupported. So if I have to deal with it, I can go back to prepare and I can actually paint that area. Actually, let's go, we want to paint it on this one. I can paint that area. Let's rotate this around. And then under the supports, we could do tree manual and then try to do that support. In this case, I'm actually just going to let it go. I've printed one of these in PLA already, and it worked okay. And I'm okay with that result. In this case, adding that painting there, you can see that it ends up adding a ton of supports there, but it also is adding supports all over here where I don't really want it. So I like to use tree support auto and reslice it. Tree support seems to use less material. It does seem to avoid certain areas. For example, we can use different threshold angles. We can support critical regions. But for our part, it's just important that we are able to identify those areas where we may have some potential problems. For my part, it's on the back of it, not a big deal. So what I'm going to do is export this. I still export G-code directly and put it on a jump drive, take it over to the machine. None of my machines are networked, just my own personal preference. But if you have it directly connected to the machine, obviously you can send it right over. All right, I'm going to go ahead and print this, get it assembled, and then we'll take a look at the final result. All right, so here we have the parts. I will say that obviously I've made a few of these things at this point, and I've learned a few lessons. I've printed, I think, 2 or 3 of them in just a standard PLA, and they printed fine. I didn't really have any major issues. When I switched to the PLA CF, the standard Bamboo Labs PLA CF, I had some adhesion problems with the back piece, so I ended up going back and putting a brim around it, just for some extra support, and it printed fine with that. Now the PLA CF has a little bit of a rougher finish, and it hides the layer lines better, so for a more final looking product it works. There's still those issues on the back where I mentioned during slicing where those overhangs are going to potentially be a problem. It's not really an issue visually because you don't see anything once it's assembled, but it's just something to consider. You have to keep in mind the orientation of some of these features. You could get rid of basically that little section at the top if you're really worried about it, but in this case it printed okay. It's not perfect, but it's fine. As far as the assembly goes and the testing of it, it went together just fine. So the little recess for the USB Micro B, the way that it works is you kind of slot the board into that and it holds it in place. I just used some Scotch tape to hold the coil in place. Again, these coils come with a little adhesive backer on it that you can pull off. Since I'm not sure if this is the final version of this, I didn't want to pull that off and permanently install it. And there may be some things that I decide to change after using it for a week or so. But everything went together just fine. The Scotch tape held. Putting it together, when you install the back piece, because of the little lips, you do have to press and flex it a bit before it snaps into place. Taking it apart can be a little bit more of a pain. You actually have to pull the back piece up and flex it, and then it'll kind of peel out. You could make the overlap smaller and make it easier to install, but this works pretty well. It actually will stay without the screws. But again, when you're trying to remove the USB, you really do need those screws to keep it from pulling the board out. Inserting it or plugging in the USBs, it's fine because we built that extra wall on the backside. As far as the overall dimensions and how it works, I think it's a little bit tighter than I probably would want for a final product. I think just based on the case that I have, it's got little ribs on the side. They tend to catch a bit. So taking it out without using two hands, sometimes it can get caught if you pull it just a little too far forward. But other than that, it seems to work fine. So again, I need to play around with it, use it for a while. I used the PLA one that I printed as a test for a few days, and I liked it. And that way I knew that it was the right direction to go. Now, when you're designing a part like this, there are always going to be some associated challenges. So if you're designing stuff for the first time, so for example, you haven't made a bunch of wireless phone chargers, then there is going to be a sort of a bit of learning that has to happen in order to make these good decisions. Generally, when I approach a project like this, first I'll get the components, in this case the electronics, test it out to make sure it works, and I will do a test. So one that I know is not the final, but incorporates all of the individual features, and that was the one that I printed first, the blue PLA one. So there are some nuanced differences between this version and the final version that we have. The main differences are really in basically the customer facing bit of this. So this little section here is a little bit more refined. These pieces are a little bit more refined in terms of the order of operations for the fillet. So you can see these are rounded here, and from the side I added a large fillet here and rounded that off and sort of rounded the bottom piece. So just visually it looks a bit more polished or more complete, whereas this one from the side just was not quite as nice. But again, when we're trying to make a test or a test piece, these are the kinds of things that we think about. We want to make something that's functional, and then we can spend some time improving the design. So visually speaking, this flat spot here would probably be better as a true arc, but in order to hold the phone, a flat spot just works better. So I ended up leaving it mostly flat there. On the back side, I ended up doing a larger fillet and rounding this area off, and I didn't include the opening here for the LEDs, simply because you can actually see the LED shining through the large USB slot. So if you do need that as an indicator, you can see it. Now, in reality, it would be nice if there was an LED on the front or the side somewhere that you could see, but the phone indicates whether or not it's charging. The last thing that I'll mention about that is, at least with my phone, there is a setting in the phone that once it gets to 100%, it stops charging. You can have it go back down to 95% before it resumes charging. If you're planning on leaving your phone on this, that's something that you should look into. Make sure that you understand what happens when it gets to 100%. If it just continues to keep trying to charge, that will eventually damage your battery. When I say damage, I don't know that it's going to cause any major damage, but it'll reduce the capacity of your battery if you just keep it topped off at 100%. So generally with chargers, I don't leave mine plugged in all the time. With something like this, because it's like a docking station or a phone stand, it can be very easy to just leave it there. So make sure that you do at least look into those settings on your phone. You can customize them on most phones, so that's just something to keep in mind. So that's basically it. I know this was a long video, and it likely is a very easy part to design, but there are a couple of nuances that go along with it. So if you found this helpful, let me know in the comments, and leave a thumbs up on the video. That kind of stuff helps it get to more people. If you want to see more kind of little projects like this, then let me know that as well. As I always mention, we've got a huge list of videos to do. We've got more scanning videos coming. We've got more design videos in plasticity and in Fusion and in Quick Surface. And we've got just a whole host of videos that I need to get to, that I'm hoping to get to in the next month or two. But again, always open to suggestions. Send any suggestions you have for things that you want to see. Some of the most recent suggestions we have are updates on configurations. There have been some changes there. We are working on some CAM content, so if you're looking into CNC machining, we'll have some of that as well on our Learn Everything About Design website, as well as here on YouTube. And we've got a couple of more like sort of prop or design videos in the works. One of them is an Iron Man helmet. That's been requested, and some other stuff as well. So lots of stuff coming, lots of stuff to do. And of course, we do still have our projects like the GPZ. We have next month in September, we're going to be doing a sort of a sponsored video for AirShaper. We're going to be doing a full car flow simulation. So I know that's been requested, and we're going to be talking about that as well. So again, any questions, comments, please leave them below. If you like this kind of content, consider subscribing, and you'll be up to date on all the stuff that we release. But as always, thanks for watching, and we'll see you in the next one.